Okay, FST, this is our last video, our last chapter. I promised myself I wouldn't cry. I need a moment. Just a second. Oh, I just graded some of your tests. I'm fine now. Okay. 10.1. Binomial probability distributions. Well, the good news is... Well, I did just grade some of your tests. Anyway, the good news is this is falling right after 8.9. It's not supposed to be right after 8.9. Notice we skipped chapter 9. 8.9 left off with what a binomial probability was in the first place, which looks like this kind of stuff. You have the either-or kind of probability situations, like heads or tails or success, failure, or the plant's going to live or the plant's going to die. This is really a pretty good segue. It's better, I think, to do it this way than to have that awkward chapter 9 in between these two things, but I guess if you hated this, you're going to hate this too. Anyway, it's not all that. So before I get on with this example, let me flash up here what the... Oh, you can't see all that. What the... Would that help? Yeah. The questions are going to be like when I call out the cards after I hand back your test on Monday. This is the stuff I'm going to have you discuss in your groups. Have a look. Okay, so what I talk about mainly in the notes here is this made-up example of you're guessing 1 out of 5 on a multiple choice question test. So it's A, B, C, D, E choices. So you have a 0.2 chance of getting it right, like a 1 out of 5 or 20%, and a 0.8 chance of getting it wrong. And when you expand this binomial with all the combinations and all the exponents cycling through the way they're supposed to, these little terms produce all of the different well, really the distribution of all the different probabilities of getting these different numbers of basically correct answers on the test. It spells out what's the probability you're going to get them all right, all the way down to, half right, and all the way down to what if you get them all wrong. So if I do that, I actually do that one here. I do all the calculations, and I kind of do it step by step so you can see all that. So feel free to pause this or look at the document that has that all out. Make sure you remember this part about Pascal's triangle. Here's all those probabilities, from getting them all right to getting them all wrong. Getting them all right is pretty low, you would imagine, because I have a 1 out of 5 chance. Guessing all 6 of those is like 1/5 to the 6th power, which is pretty darn unlikely. All the way up to getting them all wrong, which is actually quite likely. It's about 26% that I would get them all wrong. That's a 4 out of 5 chance to the 6th power. And everything in between. Here's those coefficients from Pascal's triangle. You can see how the exponents move nicely from one end to the other. Okay, when they do these graphs, though, they usually start... I always started with the success at the front of the polynomial, but the graphs usually go up on the x-axis here from 0 successes to 6 successes. I did this in Excel, and you notice for the 6, this is, as a percentage even, that's like 6,000th of 1%. So it's so tiny here you can't see it. 5, getting 5 out of 6 right, exactly 5 out of 6, that's, 1/1500th of a percent. That's still pretty low. It's not actually even visible here with Excel. Once we get up to the 4th one, this is 1% of all the blue area. You can actually see that a little bit, and then we get to 8%, 24%, that kind of stuff. So it gets a little bit bigger, and you can see it. The most popular thing that's going to happen, and you might have expected this, is that I would actually get 1 out of 6 correct on that test of 6 questions, where my chances of each are 1 out of 5. 1 out of 5 and 1 out of 6 are kind of close, so yeah, you could maybe expect that was going to happen. 0 and 2 turn out to be almost the same. 0 is a little bit higher than 2. And then after that, it seems to really drop off. If I was to connect the dots on this, I would get this nice kind of... I don't know what you call this. This was happening at the end of chapter 8, too. You get this kind of lazy, slopey, lopsided hill. Now, the reason that this is lopsided towards the losing end is because my probability of success is so low. It's really 20% success and 80% failure, so you would expect this to kind of be lumped over towards the the failure end, because that's going to happen more often with such a low chance of success. Getting 6 out of 6 right is like almost impossible, but getting 0 out of 6 right is quite possible. So this little bulge here is going to be got it down towards this end, and this kind of analysis is what we're going to be talking about in chapter 10, or at least how we start off. So this was, again, 5 choices and 6 examples. And so the next step is to take it up a notch. After all, this is April of the school year. We're ready to get kind of complicated. What if you, and I think this is all text, so this isn't very fun to watch, but, so I'll go back to the graph. What if you were to mess with the number of trials? You notice I'm not really drawing much today, I'm just sort of talking. But, we needed some fun together time, so here we go. If you increase the number of, what did I talk about first? The probability, chance of success, probability of success. Okay. The next thing to mess with is what if we, instead of talking about 0.2, we increase the chance of success and it was more like 0.3 or 0.4 or 0.5? Well, after, you know what? I am going to draw a little bit. Do I have a picture of that? Just a second. Yeah, here's the picture. If we had something more like, and I'm just going to kind of guesstimate this kind of thing, but just to get you thinking. If I had, say, exactly a 50-50 chance, let's do 50-50 in yellow. Let's pretend that was, say I had a 50% chance of success. Well, that's a really thick marker. So I'll do that in yellow. At a 50% chance of success, the hill would not be kind of lumped over here. The hill would be, I'll just tell you, the tallest bar would be the 3, and then I would kind of have this going on around it. Right? Like, I mean, yeah, it's possible I could get all 6 right. It's possible I could get all 6 wrong. But, the average kind of mean expected kind of value maximum should be around half and half. That's kind of where we're at. And now, this isn't exactly 20%. Remember this blue one? Ooh, can I change to blue just to tell you what we were doing here? The blue one was, what if it were 20% success? The yellow one is more like, okay, what if it was 50% success? Okay, this looks really dumb down here. I want to make a nice list. Wow, can I move that easily? Yeah, I can. Oh, that's going to destroy that. Okay, that works fine. Yellow is more like 50%. And if we had something more like, well, this is starting to look kind of like a nice graph. What's your favorite color next? Let's talk about, I guess, orange. If I had something like, let's do orange color now. If I had, that's kind of like the red, fine. If I had something like, I don't know, 80% success. It's a little too symmetrical with the 20, but fine. 80% success is going to shift this little bump, this little hill. It's going to be way over here now. We're going to have something more like, 5 or 6 would be my maximum. Oh, I got some funky numbers down here. And this might be a little lower. It might look kind of like the reverse of the 20. Like I'm gonna have basically this shape curve. The yellow, okay, this is a bunch of stuff in one. The yellow, the hill is going to be in the middle, and the blue, the hill was going to be at the front. So the wave is kind of going to move based on what our chances of success are, and that's kind of the first thing we mess with in these graphs. The other thing is that we're going to mess with, and I talk about this down here, is instead of messing with the probability of success and analyzing that, is the number of trials. Okay, let's go back to what if we were talking about the 20% success. Say we're still talking about 20% and we had this kind of thing. Well, this was, what was the probability that I have exactly, or sorry, I had a 6-question test. If I had, instead of a 6-question test, let's say I had something like, I don't know, a 100-question test, I would have more points along here. This whole thing might come down a little bit. I'm not sure exactly if that would be exactly the same, because now there's more possible answers now. So I don't know if anything would actually have the probability of being almost a 40% chance. This scale would be reduced. The maximum thing, whatever it is, would be, well, all you need to know now is that it would be less than 40%. This would be 100 on down to 0, and it would be evenly spread, so 50 would be somewhere around here, and 25s and 75s and that kind of stuff. But my point is, when you start to do this 20% thing, it's not going to look just like it does now. There'd be, like if I just did 12, you might expect to be a bar here, and a bar here, and a bar here, and a bar here, and a bar here. And if I went up to 24 trials, I'd have like another bar. I'd have other bars kind of in between here. And if I had 48, it'd be a little bit more. By the time you get to exactly, like 100 trials, the tops of these bars are going to be really smooth and really thin and really close together. Oh, that looks like it's kind of actually straight. It's going to be nice and smooth and curvy and, high resolution. At first it starts out as a bunch of these little towering rectangles that are kind of stair-steppy as you go up the thing. And by the time you add lots of trials, it's nice and smooth all the way through that curve. So those are the two sort of parameters we're going to mess with, and we're going to study the comparison of those two things. The wave will kind of move back and forth along here once we change the probability of success. And for any of those waves, the curve starts to get more and more ski slopey and less stair-steppy. It's pretty stair-steppy here in the original. When you increase the resolution of how many questions are on the test, or how many times you're going to run the binomial trial. All right, I think that's it. That should be enough to answer the questions I showed you at the beginning, and I'll see you on Monday or Wednesday.